Hello all. Today we are going to see RBM, which is nothing but a restricted Boltzmann machine. Brief introduction about me. I have 5 years of experience in data science and analytics, and I have a specialization in both machine learning and deep learning. I have worked on different domains such as finance, manufacturing, retail, and healthcare. So today's agenda will be, we'll see what is Boltzmann machine, then we'll see the types, then we'll see the working of RBM and training of RBM. Thereafter, we'll see some applications, advantages and disadvantages. Then after that, finally conclusion. Thereafter, we'll see a demo. Okay. So let us see what is a Boltzmann machine. Before that, let us understand who invented this. This is invented by Geoffrey Hinton in 1985. This is a particularly generative unsupervised model that learns probability distribution from an original data set and use it to make interfaces about previously unseen data. This is nothing but it sees the training data, and then when we are going to predict, it will predict based on the training value. So the Boltzmann machine has an input layer as well as a one or more hidden layers. This is nothing, one input layer will be there, and there are many number of hidden layers. This minimum one is required. Then thereafter, this neural network used by the Boltzmann machine have neurons connected to both neurons in the same layer and neurons in the other layers. So this is nothing but there are a connection between the layers. Okay. So there are typically two types of Boltzmann machine. One is known as EBM, another one is known as RBM. So the first one is energy-based model. The second one is a restricted Boltzmann machine, and the third one is it's very rarely used. Those are known as deep belief networks, and which are formed using the RBMs. That is nothing but they are stacked together. So n number of RBMs consist, and they are known as deep belief networks or DBN. So what is energy-based model? So the name suggests energy. So it is basically taken from a physics concept. So the main concept here is to minimize the energy consumption of any model. So here you can see that this is the energy equation, which is a function of V and H. Okay. So here our objective is to minimize the energy consumption for running any algorithm. So basically V and H is nothing but visible and hidden inputs. Okay, we will see what are the hidden states and input states, and what are weights and biases. And if you know the deep learning, this computer vision and all, NLP and all, based on the energy-based model only. Okay. Yeah, this is a restricted Boltzmann machine. This is a second type of Boltzmann machine. So what is a restricted Boltzmann machine? Here you can see these red colors are visible inputs. Okay, and these are hidden inputs or hidden units. There can be any number of hidden units. One more can be here. Okay, like this n number of, but minimum one is required. So the Boltzmann machine speciality is every visible input layer is connected to the other hidden units. Okay, but they are not interconnected either way, in hidden units as well or visible units. They are not interconnected, but they are connected with others, nothing but other layers. If there are any n number of hidden units, then they are also connected like that only. So this is what I have written. RBM is a neural network that is a part of energy-based model. Here also we will use energy-based model. It's not the improved version of energy-based model. And RBM is a deep learning algorithm that is a probabilistic, unsupervised, and generative. This is nothing but basically a deep learning model. And the goal of the RBM is to identify the joint probability distribution that maximizes the log likelihood of function. This is nothing but the probability outcome. What is the outcome? What is the correct output? So it will be predicted based on the probability value. Then RBM is undirected and consists of only two layers. As I told, there are only two layers. One is visible and another is hidden. There can be any number of hidden layers possible, but at the end of the day, we have to say one is visual inputs, as other is hidden inputs. Okay. Every visible node is linked to every hidden node. So every visible node is linked to every hidden node. And it is also known as a symmetrical bipartite graph. Why it is asymmetrical? Because they are connected like this. There is no symmetrical. It is not like second one is connected to second one, first one is connected to first one. It is not like that. They are connected. One visible unit is connected to all the units of the hidden layers. Okay, this is about the restricted Boltzmann machine. And now let us see the working. Okay, there are typically the two, you can say, phases of the training. One is a visible layer and another is a hidden layer. Basically here the forward phase, this is known as forward phase, and the backward is known as feed backward phase. Okay, so this is nothing but a bias. Bias is nothing but error we will add intentionally so that our model will become robust. So now let us see what are the two phases of the RBM. So generally RBM works in two phases, as I said. One is feed forward phase, another is feed backward phase. Feed forward is nothing but from visible layer to hidden layer. That is what called feed forward phase. And another is feed backward phase. That is nothing but from hidden layer to visible layer. That is nothing but feed backward phase. This happens during the training. Okay. Since there is no output layer, we reconstruct the input layer using the activated hidden set rather than the computing the output layer. If you know about deep learning, there will be an output layer. Okay, so whatever comes here, the next layer is output layer, and the result is a probabilistic in nature, and output will come here. But in RBM, the output layer is not there, so we will give the this output based on the visible layer only. So then the positive association occurs when the hidden unit and the visible input have a good relationship. That is nothing but when we train the model very well, like using bias and weights, and when all this happens properly, when the model learns properly, then only this training becomes very effective and the output is also very positive. Negative association occurs when there is a bad connection between the visible and hidden units. That is nothing but bad connection is nothing but always remember that the weights and biases are not properly trained. So this is about the working of RBM. Now let us see some practical example. You can see that these are movie 1, 2, 3, 4, 5, 6. Okay, and these are like Gen A, Gen B, and actor X, Y, Z. Okay, so here the main thing is that I have to predict if a person is watching a movie 1. Okay, what will be his suggestion? Okay, what the model should suggest that movie 2, which movie? For example, if movie 1 has a Gen A character, okay, so our model should predict or suggest that he may watch a second movie based on this proper training. Here we have to see recommendation system comes into the player. So proper recommendation, movie recommendation, any recommendation system can be built using RBM. So basically there will be two layers, as I earlier said, also hidden layer and visual layer. And these will be backward propagation and forward propagation will happen, and training will happen here, and biases we will add here. So this is about one practical example. Since there is no input, since there is no output layer, we reconstruct the input layer using the activated hidden state rather than the computing the output layer. This is not what we are avoiding output layer. Okay, we are simply returning to the input layer via activated hidden neurons. This is nothing but again we will come back to this using the activated hidden neurons. After that, we reconstruct the input using the activated hidden state. Here again the input will reconstruct. Nothing but the training will happen, weights and biases will get updated, to and fro motion will happen, to and fro backward and forward propagation phases of the training will happen. Then thereafter, whatever the comes the output is maybe the better than the previous one. Error may occur. Error can be measured as reconstructed input layers minus actual input layer. For example, if here is the output, we have to cross check whether this output is correct or not. If not, then if we take the difference between them, then we can get the error. So thereafter we can adjust the weights, then actually the training happens. Okay, this is nothing but the adjusted weight happens input into error into learning weight 0.1. Learning rate can varies from this is 0.1 to into 10 to the power of minus 3. It can vary from 0.2, generally 0.1 or 0.001 can be considered. Okay, now let us understand the training, how exactly the training happens. Okay, so there is a concept called Gibbs sampling. Okay, what Gibbs sampling is tries is that, for example, if I want to go to the center of this model, this is nothing but to reduce the error. How quickly or how energy efficient my model is that, so that it will reach to the center or the minimum local point, minimum global point. Okay, so here the thing is that when the training starts, how direction it will take, on which directions it will take, so that the minimum distance it should take to reach to the global minima. So that concept is used as a Gibbs sampling here. And another one is there's constructive divergence that we'll see in the next slide. So what is Gibbs sampling? Gibbs sampling is nothing but a Markov chain Monte Carlo algorithm. This is nothing but basically an algorithm based on Markov scientist, and that resamples each random variable from its conditional distribution, given the remaining variables iteratively. That is nothing but based on this position, the next position depends on this position. So like this arrow. So this position depends on this position. So it will go iteratively to achieve to the global minima. Global minima, when I say, that's nothing but the reduce the error. So basically, this prediction is a function, and it depends on both hidden and visible layers. If input is represented by V and hidden value by H, and probability of V of H is utilized for this. Okay, and the prediction of generated input values when the hidden values are known. Let's say that after k iteration, V of k is obtained from input value of V of 0. After this process has been replaced with k times. This what it is telling is that this is not a one time, okay? This will happen n number of times or k number of times. So that k number of times when it happens, the output prediction value will be much better. It is not like that it should go n value should go 1,000 times, but it should get one optimum value. Okay, this is about Gibbs sampling. Now let us see about constructive divergence. What constructive divergence is an approximate maximum likelihood learning algorithm that approximate the gradient. Here this is nothing but when we see the Gibbs sampling, when the direction it tries to achieve to the global minima, whatever the each individual steps taken is achieved by this probability of h of v, hidden layer to the visible. Next is visible to the hidden. Next, if another layer goes is hidden to visible. Like this, it will go. So that how log likelihood, that means how this correct is, how the probability of the value of v of h by v is correct. Initially, it will be wrong, error will be very large. Then after subsequent training, what will happen? The error try to minimize. So for example, if you can see here, v is a first step. So v dash second, vn. So up to n steps it will take. So at the end of the day, our error is going to minimize. If you know deep learning, our objective is to minimize the error by using epochs and other variables. Okay, we will see one practical example of demo at the end of this presentation. Okay, so this is the constructive divergence is used. One is Gibbs sampling, and another is constructive divergence. Here what happens here, the weights and biases all are updated in this manner. Okay, so that is nothing but the training happens. This direction is given by Gibbs sampling, and the training and everything happen using constructive divergence. Since RBMs are in use since for many years, you can say many decades, so they are very useful in, like, for example, handwritten digit recognition and recommendation engines. When I say recommendation engines, like movie recommendation or any product recommendation on social platforms like Amazon, Flipkart, Myntra, and anything. So all this way we can use RBMs as a recommendation engine. Then for radar target recognition, this is nothing but a defense application to detect the enemy aviation or enemy object. So there also we can use this RBM machines. Okay, generally this dimensionality reduction, this comes in machine learning or even also deep learning. So there also we can use RBMs. Okay, dimensionality reduction is nothing but reducing the number of features so that our model life becomes easy when we train it. So another application is topic modeling. So these are typical applications of RBMs, you can say. Let us head to some advantages. Okay, basically this RBM is computationally efficient and expressive enough to encode any distribution. So it is like basically you can say energy based model and energy efficient model. Okay, so and it performs non-linear transformation, making it simple to expand and capable of providing a layer of features that is hierarchical. That is nothing but it is non-linear. It is not like that it is y equal to mx plus c. It can go, training can happen in non-linear direction so that model can learn in a very versatile way. So that is one advantages. And the other are like due to the limitation on connection between the nodes, it is faster than the traditional Boltzmann machine. For example, if you know about traditional Boltzmann machine, there was a connection between visible layers also. So that is removed. This is an input version of traditional Boltzmann machine. So when you remove the connection between the nodes of the same layer, then you can say that the training is fast. So accuracy is also improved. Next advantage is that the hidden layers activation can be incorporated into the other models as useful features to boost the performance. For example, if one model is trained, okay, that hidden layers, whatever the output or weights and biases are there, that we can utilize for the other model training also. So that we can avoid again the training on the same data set for different application, okay, or to enhance the application by using this previous data. There also we can use RBM's machine. And another advantage is that in training dataset, it outperforms the autoencoder in ignoring the random noise. If you know about autoencoder, this is nothing but encoding the features. So actually, RBM's what it does is it is outperforms. That is nothing but it is faster than the autoencoder, because generally in autoencoder what happens is there is a random noise. We can say that some error occurs generally. So that we can eliminate in RBM machines. Okay, now let us see some disadvantages. Training is more difficult because calculating the energy gradient function is difficult. This is because there are only two layers, and one more thing is that every layer is connected to the every input of the visible layer. So at that time, what happens? The training becomes a bit difficult, because at the end of the day, we have to optimize the energy function. And one more disadvantage is that the constructive divergence key algorithm being used in RBM is not well recognized as the backpropagation algorithm. That means what? This is not well known. Okay, this is being used, but there is no in-depth analysis or R&D on this divergence key algorithm. It's, what is the backpropagation happening? How the work is happening? It is a bit difficult to understand. And also the weight adjustment, because this weight adjustment comes in training time, backward and forward propagation. So that based on the error, again it has to adjust the weights. So these are typical disadvantages of RBM. So you can say that if you know the deep learning has a like concept, and it is abstract is based on RBM only. So RBM you can say as a first deep learning model which is established. Okay, so finally conclusion is that RBMs are unsupervised two-layer neural network models that learn from the input distribution. So this is nothing but again a neural network. This is a very basic two-layer neural network. Okay. So RBM and the algorithms used for the training and optimization have undergone numerous modification and advancement. So in the present generation, RBMs they have improved over it, and some algorithms they have added to it, and different modification has done, and it is working effectively. And finally, the infinite RBM and fuzzy RBMs are two examples of modifications that have been made to the original RBMs to improve the effectiveness and responsibility. That is nothing but here, when we modify this, what are the two RBMs came out of it is infinite RBM and fuzzy RBM. And these are very useful for different applications. Now let us see some demo of RBM, how it works. Here I have taken one movie recommendation system. Okay. So basically these are the imports. If you know NumPy, Pandas, and Torch, and all these are imported for training. Importing these are the libraries. We are going to import the dataset. Okay, the dataset I'm reading using the Pandas file. Okay, and the engine I have taken as a Python, and I'm encoding using the Latin-1. Okay, and here I am having like a dataset of movies, users, and ratings. Okay, typically there are some movies, and there are some users, and what are the ratings they have given. Okay, so when I run this, okay, you can see this movies.head. There are some movies, Toy Story, where this is nothing but the year of the movie released. Okay, and what is its category? This is animation, adventure, comedy, romance, drama. Okay, like this, few only I have taken. Okay, when you do movies.head, only the first 5 elements will come. This is about the movies dataset, and next is users dataset. Okay, so what are the users like female, male, and like this? Okay, so there are some typical other dataset ages and other things are available here. Okay, and the ratings, how users have rated it. Okay, so like a 5, 4, 3, like based on the rating they have given. Okay, so this is typically movies rating dataset. Okay, so here we will see how to prepare before training our dataset. Okay, so when I read the dataset, I have seen that there are some tab values are there, so that I can remove it. So I am doing here a pre-processing. So I have removed all the tab values and some in. Okay, so based on that, and I have converted them into array. So basically, I have read the CSV file and I am preparing it. I am removing by delimiter equal to tab. Okay, then I am converting into numpy so that I will convert all this into integer. So you can see these are the typical preprocessor data. Okay, so both the training and test data is there. And here we have to get the number of users and movies. Okay, when I do the maximum test underscore stat data from initial to 0, so it will give the all the users data. Okay, similarly movies, it will give all the movies data. Okay, so after doing that, I am converting the data into an array with users in lines and movies in columns. So users all will be in the line, and this movies in come in a column, so that what is the particular user has given, what is the rating. So that it will be very useful. I have created a function here. So based on that function, it will convert the movies and you can say users into lines and columns particularly. Okay, thereafter I am converting the data into torch sensors. Torch sensors is because it will have a very helpful while training for the RBM machines using tensors. So that is it can be achieved by using torch dot. There is one application known as flow tensor. So it will convert all the tensor data, sorry, training set into torch values. Similarly, test value also it will do the same. So next is I am rating like movies into binary ratings like 0 or 1 means liked or not, means 1 is liked, 0 is like not liked. So I am converting all those into binary values 0 or 1. Okay, so that we can do it using this basic Python function. So part 2 of this is building the RBM model. So here comes our main neural architecture here. So I have defined a class and then I have written some functions over it using the oops concept. If you know, these are self and all these are basically oops concept. Here I am initializing, okay, the NH and NV, these are the input values I am taking, okay, and I am using it random, I am choosing. Then I am taking the samples, okay, sample of the hidden layer, okay. Next I am taking the sample of the visible layer, okay. Then after taking all this, the training happens in this way. Okay, this is a basic RBM function where the training is happening. Okay, so after that, I am calling RBM function using these inputs, and I have taken a batch size of 100. Okay, this batch size is nothing but if you know the epochs in deep learning, this is used for training over 100 batch of total data set. So there will be iteration after every 100 batch. Okay. So next the training happens. Here you can see that, okay, number of epochs equal to 10, batch size is 100. So it will run 10 times. Okay. So once it starts to run, initially the error will be higher. Okay. You can say error or loss function. Okay. This is a Python code I have written, and you can see that initially the loss is 0.29. Okay. And I run this code for 10 epochs. Okay. The nothing but this function will run for 10 times. Okay, the loss value gradually decreases from initially 0.29 to 25 and then to 4 and to 5. So at the end of the day, our main aim is to reduce the loss. So this is basically how RBM training happens. Okay, now let us test our model, which is given what is the value. Okay, so here I have given, I have taken this sample Python code here. Okay, when I give the value here, what is the output? So when I give the value to this, the test loss came is 0.23. Okay, so this is very pretty similar to our training happens. Okay, this is around the same value. Okay, so this is how our RBMs works. So this is about the basically demo of RBM using Python, and here the movie rating is happening. So when you do this, though you can say when you give the output whether the movie is positive or negative, it will tell. So this is about RBM and its demo. Thank you all. Thank you for joining.